Hey, Sakit. Sakit, can you hear me okay today?
Yes.
Okay, great, great. Hello, Vihan. How are you doing? Hi. So we have.
Hi.
Hi, how do I pronounce your name? Is it Atanu?
It is Atanu. This is Aruni. I am Atanu.
Oh,
Hi.
you are
Hi.
Atanu. Hey,
Hi.
Arun. How are you?
Thank you very much for making out this time. We were struggling with this program,
No,
and I have had a chat with the boys. They looked into it and they said that it's not going to happen.
no, it's easy. No problem. We will try to help. When is the competition for you guys? The regionals?
March.
Oh yeah, you have time. You will be flying with it.
Hi, Ginjal.
Hello.
How are you?
Doing good. Good to see you.
Fantastic. Same here. We got a few members of our team today.
Hello, guys. Hope you all can
Hello.
hear me okay.
We heard that you are going to conduct an interesting session.
I don't know about interesting. I just saw some chat. uh, so I said, yeah, we will just do it. I was planning to do that for my team anyways, because we also have a bigger team here. And some of the members missed the PyBricks session that we did in August. So I was planning to do it, and this is like the last day of my holiday. So I was like, let's just get it done today.
Right.
Hi. Hello.
Hello, how are you?
I'm good. Today you'll get to see the full Cardiff team.
Oh, very good, very good, very good, very good. Yeah. So let's give like a minute or two so that maybe
Yes.
other folks can join.
Yes.
And yeah, we can then get started. So what I thought is maybe we could just keep it more interactive, but
Yeah.
you know, like my main thing is to just take you through the PyBricks interface and how the team Monet Masters has used it, right? Now, I think many of you who are on the CERC advisors group, you might have seen a link to where all our code is stored. So you can also, use that as a reference, basically. But you can see it's very simple. We've not kind of done very complicated because we have younger kids. So, Vihan, for example, is here. I think he's gonna turn 8. Then we have Yuan, who's just gonna turn 8 in February, right? So we wanted all of them to be able to code. So that's why we kept it very simple, and it's actually much more intuitive. So yeah. So from the team here, who has already downloaded, let's say, PyBricks, or I'm just trying to understand how much, like, how many of you installed PyBricks on your robot?
We've done
So okay, this is which team?
Sayadri Rangers.
Oh, Sayadri Rangers. Okay, okay, good. So you already done that. How about the Cardiff team?
I just have a question about this actually. Is
Yeah.
there, because it says they'll delete certain firmware and install new firmware. Does
Yeah.
that mean that any of our Spike Prime code will be useless?
Yes, that is true. That is true. So
Because we tried importing it and there was a lot of weird symbols, but I don't even know if it actually works.
yeah, okay, maybe we can get started. Let's say there's a 4 minutes, right? Let me just share my screen and we can get started. Okay.
Angel, are you recording this, by the way? Because
Yes, I think this is being recorded into the cloud. So yeah, it is. Let me
is it all right if we record it, or will you share it?
Um,
If you share it, that's fine as well, because we might revisit this
We
again.
can't record it ourselves because we're not the hosts.
Yeah, unless he.
So
is
to
approved.
me, it shows that this is recording to the cloud when I said
Fair enough. That's fine. That's
So
fine.
I'm hoping that it does what it is supposed to do and doesn't let us down.
You want me to double check?
No, it's fine. Yeah, I'll still kind of check. Yes, it is recording. I can see it pause, stop recording. So it is definitely recording to the cloud. So yeah, that's good.
Thank you.
Right. So can you all see my screen?
Yeah.
Yes.
Okay, good.
Yeah.
So I think let's just start. So in general, so PyBricks, right? Basically, it's let's say another option that you have for working with Lego hubs. This is their website. And I think, as they say, robotics made easy. It is true. They have started with something, recently they are also offering like a block coding, but actually they're charging money for that. It's like 80 pounds for lifetime access, but I don't think it's needed. You can just use the Python. That's more than enough. And the way you can get started on this is basically quite simple, actually. If you are on Windows, you can just download its app. Even on MacBook is fine, but there might be some issues in porting the programs between, let's say, Mac OS and Windows. So you might just want to be careful. Just use Windows all the way, and that'll be fine. So I think that's basically it, right? So yeah, I think in terms of coding, it's as straightforward as you just click on this, and it will take you to its web interface through which you can code.
Settings.
Yeah.
Where is Zoom settings. Preferences.
So can you all see the screen, everyone?
Yeah.
Okay.
Yes.
Okay, so that's basically it. Now you also have an option to download an app, like version for this for Windows. So you could do that. I have that downloaded here, and that's where we are deciding to work. Now keep one thing in mind, that you will have to save the program as you go along, right? Because it doesn't have, let's say, if you by mistake, delete one of the program, then there is no way to recover it. So this is one good practice that you have to keep in mind. Now I just wanted to tell you how we approached it, right? So first and foremost, what we did is we built a template. Actually, to write the code is quite simple. Let's say if you want to start fresh, then you can do it. But just to give you an example, right? How do you start? So you just click on this plus button, and then it gives you now this option of code with blocks or Python. So as I said, right, if you want to do something with the block, then they are charging this, but we just select the code with Python, give the name. We just use, some names, and then you just select this option here, which is the Spike Prime Hub. That's all you need to do. And then it creates this example here, right? So so what it has done is this lines 1 to 5, it's actually importing all the key programs that you need. So it's just like a setup. It's a template. So you don't even need to do anything. It just says, get all the programs related to Prime Hub, get all the programs related to the motor, color sensors, ultrasonic sensors, force sensors, get all the programs related to the buttons, the color on the display, the direction of the sensor, the ports, the side and the stop. And I think the most important one in my mind is this, the drive base, because that's what we end up using most of the time. That's what it is mostly about. And then you also have some tools, like if you want to, let's say, insert weight or some kind of a stopwatch. Now, we don't use all of this. We use only a few, but it's just a good practice to keep it as it is. So we have done that. And then it also initializes the hub equals prime hub for you. So this is what it does as a default. Okay, so you don't need to do anything about it. You might want to make a few changes, and what those changes are, I'll tell you later. So far, clear, everyone?
Yeah. Yes.
Okay,
Yes.
so that is it. Now, what we did as a team, because we had different groups of people working on different things, we agreed on a robot, and you just need to have one setup file. So we said that we'll have a common setup file, and nobody should change that setup part because that is tied to your robot. Okay, so what does our setup look like? So can you see this PyBricks _template.py here? Can you see this, which I clicked? Yeah, so this is our template file. Okay, now how did we build the template file? So you can see lines 1 to 5, right? They are all the same from what we got up until hub, prime hub. So like line 1 to 7. The only thing I added was this hub menu, multitask, and run task. Now you need this for doing some of the things that we did. Again, we'll come to it, but these are the only things that we added afterwards. But other than that, it's very much the same. Now, all you need to do in your setup is just 3 things. Okay. Step 1 is you initialize your robot, like drive base, which is you are telling the program how the dimensions of your robot, right? Where is the front motor? Where is the left motor, right motor, and so on. Then you have to initialize the attachment motors. So we are using the advanced driving base that is from Lego, right? So we know that, in our robot, we have a front motor and a back motor. In your case, like, depending on what robot design, you may have a left motor and a right motor, right, for your attachment. So you can give intuitive name as you like. And the third thing that you need to do is to initialize the left and the right color sensors. So we are like, as a part of this advanced driving base that we are using, again from Lego, they have 2 color sensors in the front of the robot. So we are also initializing. Now, I don't know what your robot is using. If you're using force sensor or ultrasonic, people normally don't use it. I think this is like pretty standard combination. So we've just stuck with it. But again, I wanted to give you an idea that this is specific to how you do it, right? Now, if I go to first step, so you can see we have written down, right? Initializing both the motors. And the one thing to keep in mind, the way the robot works is when you are kind of, running a robot, the 2 wheels have to move in different directions. One is moving clockwise, another one is counterclockwise. So what we are doing here is basically the left motor, you have to just say run counterclockwise. So we are just saying left motor, and we are assigning that motor to port B. And we are saying that the direction should be counterclockwise. For the right motor, we are saying it is connected to the port A of your robot, of our robot. And we don't need to give the direction because by default it assumes clockwise. But if you want to, you can just specifically say direction dot counterclockwise. Okay, so this is the first part where you have just told, this is my left drive motor, this is my right drive motor. And we have said that the left drive motor, which port is connected to, and it should be counterclockwise for the robot to move forward. Okay, so that is the first part. Okay, any questions on this one? No questions. Okay, next thing is that we initialize the drive base. So drive base is basically, this is, you remember we imported this import drive base over here, right? This is a set of programs which actually just kind of, has a very useful, let's say, movement blocks, turn blocks, and so on. And you have to just set it up based on what the definition we did. So again, now there are 2 things that you need to know here. One is what is the diameter of your wheels. Now, in the advanced driving base robot that the team Monet Masters has used, they're using the larger blue wheels. So we actually measured the diameter of that is 88 millimeter. So all dimensions are in millimeter. So we have just written it out as 88 millimeter. So in your case, if you have smaller wheels, you just, measure it and write that value in millimeters, okay? And then the other thing that the drive base needs is the axle width, which means from the center of one wheel to the other, the width of the robot. So let me just see. Okay. So this is the robot that I have. And the way you measure the axle width is just literally the middle of this one side of the wheel to the other side where it touches the ground. Okay, it's pretty much simple, right? That's how they ask to kind of measure it. So when we measured it, we saw that it is 145 millimeter. Now you need to, again, do these 2 measurements for your robot. Okay, what is the diameter of this wheel? I think this is standard. Depending on what you're using, you can just find it online. It will give you, but this value, the axle width from the, where the wheel touches, that you have to measure for your robot so that you keep it. Now, once you found that, then you just initialize the drive base. So we are calling our robot here drive_base. Not a very good name. We could have used something like Bumblebee or whatever, right? But basically it's whatever you feel like. If you have a robot name, I would just say probably, use something like that, whatever your name. And then you use this drive base, then you say left motor, right motor, you give the wheel diameter, which is 88, and axle track is 140. So now you are setting up the drive base. The next thing that you do is we use gyro. So we are saying that for this drive base, use gyro when you are doing turns and so on. Okay, so we are enabling that. And I think it's very important that you use this. Otherwise, your accuracy will go down very badly, right? So you need to kind of just make sure that you have that. So up until now, we set up left motor, right motor. We set up the drive base. So our robot is ready. Then it's pretty simple, right? You just say, the front and the back motor. So these are our attachment motors, and we know where they are connected. So our front motor, which we are calling as front_motor, is basically, I'm just saying that there is a variable called front motor, which is a motor connected to port B. So that's where we have connected on our hub. You say back motor is a motor that is connected to port C, and that's pretty much it. Now, later on in the program, whenever you want to access those motors, you just use the name front motor and back motor. Okay, same thing when you want to use your robot, do something with the robot to move it forward, use this drive base. That's what you'll see it, how it goes. Okay, and then the final thing we did was to initialize the color sensor. So we have two color sensors as well. So, looking at our robot, we have connected the right sensor, the right color sensor to port F, and the left color sensor is connected to port E. Now, again, I don't know how you have it. If you just have one, you can just say, color sensor and just give it some name. Okay. So that's it, basically. That's pretty much it, what you need to do to set up your robot. Once this is done, it's fairly intuitive from there on. Okay. And what we have done is this part, we encourage that nobody touches it. Okay, this is like the common template. No one should touch it. Once it is fixed for your robot, once you have fixed your robot, there is no need to change this. Okay, this is same. And then we added some comments saying, okay, this is how you write the code for the robot. Now, if you think about the kind of maneuvers you need in all the missions, it's basically move forwards, turn left, right, move backwards, right? Use something with the motor, or if you're using a passive attachment, use a passive attachment, right? That's all what you need to do. So basically, all that you need is just covered through what we have, defined here. Now, I'm just talking about the PyBricks template. So we built this. Then what we also used to do was we had some example commands just kind of put in over here, right? And so, we could try and so on. So I'm not going to go through all of them, but just wanted to give you an idea of the setup before we go into the command, the runs and so on. Now, any questions so far on the setup? If you have, for example, if anything is specific to your robot, something different than what we have used?
We have modified our robot a bit. So, like, for example, instead of one of the color sensors, we've actually added I think it's called an ultrasonic sensor, the one that measures the distance.
Okay.
So I was just wondering, is there any sort of code that we need to initiate that?
Yeah. Are you using it?
Yeah, we should be using it.
So yes, you must be able to initialize that. So if you are using it, let me just see, how can I? So documentation is your best friend. Okay. So they have these documents. So which sensor did you say? Is it the force sensor?
Sorry?
The ultrasonic
Distance sensor.
Okay, ultrasonic sensor, right? This is the one. Yeah.
Mm-hmm.
Yes.
Yeah, that's the one.
Yeah. So yeah, that's basically that's what you do. So you can just say ultrasonic sensor dot port. That's all what you need to say.
Okay.
Yeah. So you can see it says class ultrasonic sensor and in brackets port. And if you want to go down, see, they will also give you examples. See, initialize the sensor. Okay. It says eyes equals ultrasonic sensor port dot A. Now what you do is you just copy this line and basically let me just copy it for you. Okay. So you copy this line, go into your, I'll just do it in the, let's say test. We also had like a sample and you just do it over here. See, right? That's it, port A. So do you know which port you are connected to?
I believe it's port.
I'll give you the report.
Port. Thank you. Oh no, I remember now. Yeah, it's port B. Port
Yeah.
B.
So that's it basically. So you do it like this. Can you see it? So here they have
Yep.
called eyes, but you can give some sensible name that makes sense to you. And you just call it ultrasonic sensor port.b. Now, if whenever you want to use this, you just use this variable eyes here or whatever name you have given. Okay. That's all.
Thank you.
Okay. Anyone else? Any other questions?
So Kinjal, the idea is once you have this basic setup ready in one file, you then just include this in other programs, is it?
Yeah. So basically, you just save it as a template.py. And then what you do is, so how we would do it. Let's say I have this template, right? Then you see there is these things, rename. Then you have this copy, duplicate. You just say duplicate and give your name, whatever, run _ demonstrator, right? You don't need to say py and it just duplicates. So it created this thing, right? So here is I have opened that. And then I just move on from there, right? That's the whole idea. Is like you don't like setup, we should not touch, no copy paste, and you only modify the stuff that is after like the setup.
Right. Okay. Thank you.
Right. So and then of course, you can save this and you can save, so that's export, and you can delete this. Now, one thing to keep in mind that once you delete this, it's irrecoverable. So make sure that you kind of save it and yeah, somewhere, so you know that, and I'll come to that as well later, but for now I'm just deleting. See, it says the file demonstrator will be permanently deleted. This cannot be undone. So yeah, you need to just save your files. Just need to be careful with that. So okay, so that is the setup. Now let's actually show you how we have used this going forward, right? And I'll take our run one, because that the run one that the team has created is about 130 points in, let's say, 22 to 23 seconds. And it's the one that is very well documented and so on. I mean, others are still there, like writing up the what do you call, comments. So yes, I think setup portion common, we don't do it. So this is how we are using. So so our first part is that basically we start from the left home area, and then we will drop our masterpiece along with another museum curator and the audience member. That's like our first part. So you can see how we are actually, let's say, writing the comments, right? So anything after hash is a comment. So, we say drive the robot to drop the art piece to the museum director. And anyone remembers what is this drive base? Cardiff team, anyone? What is drive base?
The motors?
Yeah, it's your robot. It's the robot dimensions and all. That's basically your robot. Yes, it's the drive motors. Yes, Pinak.
That's what I was about to say.
Okay, good. So that is it. So that's what we used here, right? This is the drive base. But looking back, because the team has named the robot Bumblebee, we could have used Bumblebee here as well, right? So again, don't get confused. I don't think this is the best name that we have used, because this drive base capital and this drive base are similar, but actually this should have been something more intuitive. So feel free to like have some better name. But now whenever I call this drive underscore base or whatever name I give, actually I'm calling all of this as a pair, right? Basically, it will get me all the properties in this. That's how the code works. Now, if you look at, the first thing you do is straight, right? So we are just saying drive base straight 407, start from the home area. So everything is in millimeter. So it's like 407 millimeters. Move on. Okay, then we need to make a small turn, right? So this is another thing that will help you. So you also have this called drive base settings, and then you have turn rate, turn acceleration. So turn rate is basically simply the speed at which the robot is turning, and turn acceleration is like how fast it accelerates. Okay. Now you have these two values, and it actually has, it will calculate the default value automatically. And we've found that it works very well. But sometimes to improve the accuracy, right, especially in this case, what is happening is when we were turning, our attachment is passive and it's open from outside. So when we were turning, it was turning very fast, and it was throwing the the mission models out. So what we did is we reduced the turn rate to 80, okay, and the turn acceleration to 300. Now there is a way you can just get the default values, and you just say print drive base settings and two braces. So let me just show if I have that command somewhere here. So can you see this print drive base settings? Can you see this command that I'm highlighting right now?
Yes.
Yeah, this one, print drive underscore base dot settings and then colon. So you can just use this beforehand, and that will give you the basic values. And then you can multiply, divide, whatever. You can say, okay, this is what the speed is giving. Shall I increase it or decrease it? You can play with that a little bit. But before you do any run, you can always kind of, execute this command, and it will show you on the panel. When it executes, it will show you on the panel in this code, and you can use that as a reference. Okay, so that's what we were doing. So basically, we are asking the robot to, we're making the settings before turning. Then we are saying that turn 57 degrees. Now, negative 57. So this is really good about it, right? Like that, if you give any negative value, it's left, positive is right. Okay, on the turn, it's that intuitive, right? Just give a negative value, it will turn left. Give a positive value, it goes right. Similarly, when you are moving forward, you just give a positive value. So you say drive base straight 407. And if I said minus 407, then it will move backwards. That's all what you need to know. So what we are saying is drive base straight, turn at 57, like turn left by 57 degrees, and then move forward by another 90 centimeter. Okay, that's our path that the robot takes, and it drops it. And you can see we are just writing down for each and every line, we are writing a comment over here. This is very helpful because, after you have written the code and let's say 1 or 2 weeks passes, you will just forget it. Why you wrote that, right? You will say, why did I write this 407? I don't remember what it was. So it's always a very good practice for each and every line, just write the code. So it also helps other team members to learn, right? Because not everybody will be working on all the codes. So for the readability, it's very important. So this completes our first part of the run one. Okay, then another thing what we do is, okay, once it is done, then we say, okay, drive base turn minus 32. So anybody remembers if I say minus 32, which side it will turn?
Left.
Left.
Okay, good. What's the next one? Drive base straight minus 180. So where will it go? Forwards, backwards?
Backward.
Backward.
Yeah, got it. Okay. So this is what we are doing. So we are saying turn the robot a little bit left and then come backwards towards the light show, the big light show in the middle, right? That's where the robot is coming. Now, I want to give you another example of how we are actually using let's say, how we are trying to run things in parallel to make things faster. So you can't do it everywhere. Now, in our case, what is happening is we have front and back motors. Okay. And what we were doing before is we were first running the back motor to finish the mission. After finishing that, we had an arm that was going down. But the fact is, you don't need these front and back motors to run sequentially in this case. So we actually defined a function that allows it both the back and the front to happen at the same time. And in that case, you actually save 2 seconds. Now, this is very important when you are running short of time and you're trying to do all the missions. Those 2 seconds do count because it helps you somewhere else. So basically, we just defined a function. This is it. You can just copy paste this. So you say asynchronous function define front and back. That's the name I've given. You can give any name. And await means you wait till everything is finished here. That's what we are saying. And then you can see what I'm doing is this multitask keyword. In that, I'm saying back motor. You run at a speed of 500 rotations, millimeters per second, and you run minus 1650. So now anybody remembers what is a negative number mean?
Yeah.
Anti-clockwise direction, right? And then at the same time, you can see that the front motor, I am saying that run it at this speed and run the arm down, basically. So, if you have a Doger arm, minus is down and positive is up, right? So I think you'll have to play with the sign so that depending on your robot. So this is just the definition of the function. And then all you are saying is run task, the front and back like this. And the moment you execute this, it will just do both the things together. So this is a neat little trick that you can play with. Now, again, you may not need it. We just did it because we were running short of time. You could actually just have 2 commands, the back motor run angle and front motor run angle. So what we are doing here is we are running back and front motors at the same time through this method. Okay. Any questions on this one? Because this one could be tricky, but I think you might want to use it, let's say, if there are places where you can do this. Okay, any questions? Okay, let's carry on. All right, so just a few things on this multitask, right? If you want to do the multitask, we do need to have this run underscore task and multitask added to the PyBricks, setup, right? So just keep that in mind, otherwise it will give an error. So that was the reason why I said I added these 2 options in the file. Okay. Yeah.
So do we need to add any of these functions or variables into this PyBricks tool line of code?
So which one you are talking about? You mean run task or multitask?
Yeah, are they variables or what are they called? Functions.
Yeah, they are kind of functions. Run task and multitask are functions.
So do we have to add any functions into the PyBricks tool list?
No, you don't. So I think as long as you are giving these two keywords, right, here, right, when you are kind of just importing, you are importing all the relevant groups of functions, you can then use them over here, right? Just like I have
Okay.
done. So I can't use this multitask and run task if I have not imported them here, right? If
Okay.
I don't import them here, these two, you see this run underscore task and multitask, I cannot
Yeah.
use them if I have not imported them. Okay, so that's the only change you need to do. Other than that, that's fine. But you have to define this, right? Like your function, like this front and back motors that we had to define. So you have to define it, and yeah, you can do it.
Okay.
So,
Thank you.
so once we finish this M11, then we go to the M5, which is the augmented reality statue. So again, you can see mostly we are only using drive base. Straight, move it 75, turn it right by 43 degrees, drive base straight to 175. So, move forward again. And then what we are doing is, see, so earlier, if you remember, my turn rate was 80 and the turn acceleration was 300. Okay. So this is lower than the default value. So I wanted slow turns. But now for the virtual reality statue, you need to flick it very hard so that it opens quickly, right? So what we are doing is we are increasing the turn rate to like 202 millimeters per second. And the turn acceleration is 910 millimeter per second square, right? So it's all in millimeters. And what it will do is it will really, the robot will flick very quickly, very fast, so that it will just open the virtual reality statue fully. Okay, and then you say drive base turn by 87 degrees. Okay, so it will just turn to base quickly to open the statue, and it executes that. Then you can see again, we say drive base straight, move forward, turn by 137 degrees so that it moves in the other direction. Then again, here we are using another function where when the robot is moving forward, we also want to raise its top arm. Okay, so this is just another function. So it's not the same as back and front motors. What I'm saying is when the robot is moving front, raise the front arm. Okay, so that you can do, but you can't do like, move forward and turn at the same time. You can't use the same resource in a multitask manner. It needs to be different resources. So you can, let's say, combine front and back motors, right? You can do that, or you can move forward or backwards along with front or back motors. So you can do it that way. Okay. So here what we are doing is run the front motor, to kind of raise the arm up, and while at the same time driving the base by 40 centimeters or 400. Okay, and then we do that. Then we turn the base to 90, move it a little bit forward. And this is how we use the attachment motors. So here we say front motor run angle per 400 by minus 280. Does anybody remember what is negative in the case of attachment motors, up or down?
Down.
Yes,
Down.
that's right. That's right. And then we just give it a little weight. So, again, this will come from practice. Sometimes when you execute a mission, you may just need to give it a few milliseconds so that it stays in that place. Many times you push it and you come up quickly, the mission comes back up. That's what we were finding. So we added this 300 milliseconds, and then you just say, okay, move the motor up and go back, right? And then what we do is, like when we are going home, we are increasing the speed of the movement. So up until now, we were using the turn rate, okay? Turn rate and turn acceleration. That was for turn. You could also set the straight speed and straight acceleration. That's when the robot is moving forward or backwards, okay? So we are just saying straight speed to 600 and straight acceleration to 1200, so really high. And then we are just asking the base to actually do a curved movement, right? So we had to experiment a little bit of what is the size. So minus 600 is backwards, I think. And what was this minus 110? I forgot that. Okay, no, this is the speed. This is, okay, this one is the radius. Let me just see. Right. So the other thing you can use is, so can you see this is what is happening? So here you go, right? When you basically are typing in the commands, the good thing about PyBricks is it suggests all this completion. They call it as a code completion engine. So here it is actually giving you, so drive base curve. So first is a radius, which is a number. Then it's like how much angle you want to curve. Okay. And then what do you want to do when it stops? Now keep in mind that whenever you are stopping, the last the last movement of your, let's say, run, it should always be stop coast. Otherwise, the robot will keep on trying to get into the same direction, and you may, like, if you pick it up or something like that, it'll keep going on. So just in the last movement command, you just add stop.post. Otherwise, you don't need to add it. Okay, and that's pretty much it. So now, if you analyze this whole code, right? This is, I think, one of the most complex programs that we have. Majority of it is just straight moves, left, right turns, right? Front and back moves, and a couple of places we just kind of combining the movement of like front motors, back motors, or moving forward and kind of moving the arm down. That's all what we are doing. Okay. So does this help you guys?
Yes, thank you.
Yeah.
Yeah. And I also want to give you an example. Like our run 5 is really straightforward. Look, we just have it. Run 5 is literally the camera. The camera, we just push the camera through a simple attachment. And all we are saying is drive base straight by 38 centimeters. And then this stop dot none means don't like decelerate, right? Just go there and come back quickly. And then you can say drive base straight backwards. So move forwards, backwards. That's it. This is our run 5. Okay. Run 6, you can see same thing. We have the same setup. And then we just kind of say, okay, look, drive base straight by 25. You change the turn rate depending on, what you need. As I showed earlier, you move it backwards, move forwards, use your front or back motors, do what you need to do with it. And that's pretty much it, right? So the key commands that will come is drive base, straight, drive base settings, drive base turn, and drive base curve. That's all what you need to know.
Sir,
Yeah.
how do you swap between two codes?
How do you swap between?
Two codes, like can you store
Oh,
multiple?
yes, good questions. Okay, now here you go, right? So I sent a link, but do you see this? This is what I have as a main program. Now, so when like all these programs that we are written, run 1, run 2, 3, 4, 5, and 6, when you are testing out your code, you can just like directly, once you have connected with the Bluetooth, you can just press this play button here and you can like, run. But once you want integrated, all you do is you create a program, which we have called main program. And the only thing you need to do is this hub menu, right? That's all what you need to do. And this is it. Basically, it's a very simple program where you say, we're saying that in the hub menu, give options from 1 to 7. I don't know if you have 10 programs, you just go up to 10 or whatever. And then you just write this code. So you say if selected 1, okay, then you say import run 1, 17, 12, 23. So now keep in mind, so you see my file name here, run 1, 17, 12, 23. So without the .py, you just give that name over here. Similarly, run 2, 17, 12, 23. So that's the convention we are using. Name, the number of the run and the date on which we updated the script. So that's import this to blah, blah, blah. And when you actually load the code, right, you just load this main program. What it will do is it will load all the programs and it will show you the hub, right? So you just select 1, 2, 3, 4 and just run it. So you will get the same functionality like you're getting on the Prime. Like as you got to the Prime, and that's it. That's pretty much it.
So you mean to say while downloading, after writing the main program, you only download the main program on the Robo and all the other imported programs will automatically get downloaded on the Robo.
That is right. That is right. That is right. The only thing to keep in mind is all these names should be correct, right?
Yeah.
So let's say if this is run 1 something and you don't have that file open here, it will give you an error because it can't load, right? It can't import that. So it's basically importing that program as a function, right? That's a good way to think about it. So yeah.
So Kinjal, this is helpful, but based on the same principle that you said import, right? I was just wondering if you go to one of your run programs, run 1, run 2, run 3.
Yeah, let's go here.
So you created them based on the template, right? Okay. You see that a lot of the template code is repeated in each of the files. Can we not just import the PyBricks template.py into this file and not have this first 20 lines of code or 30 lines of code?
I think it is quite possible. It is definitely possible.
It's like your hash include in C or something like that,
Yeah, so I think what you could probably do, and it's a good thing, we did have a think about it, but now the kids, because they have the competition on 20th, So they are like, we don't want to change anything, right? It's working and so on. But I agree with you. I think what might be possible, right, is that in your main program, basically, right, you just do the whole setup in your main program.
Correct.
Okay, and then when you import the run, it should basically just start from your code. Like
Correct.
literally, you
Rather
should
than
only have this
code.
code, right?
Yeah.
You can only have the code, right? That I think that should be possible, maybe worthwhile for you to try. The only thing to keep in mind is whatever names you use in your main program, like, for, let's say, drive base or whatever, they should all be consistent in your other code, right? You just have to make sure that you're following consistent naming, and it'll be fine. So I think that is also possible, right? It's a very good point, actually. Yeah.
Yeah, Kinjal, how we are defining these letters? Because
So- Sorry, I didn't get the question. How are we defining what?
these letters in the main program, you select hub menu, 1, 2, 3, 4, 5, 6, 7.
Yeah.
How we are choosing that if selected is equal to 1, 2, 3, I'm not sure.
Oh, so let me show, right? So if
You get 1, 2, 3, and
You get okay, sorry, I don't know.
so
Yeah.
you get 1, 2, 3 as menu options on the robo
yeah,
screen.
so see this has it all loaded, right? So can you see this one?
No, we can't see it now actually.
Oh, so I'm just let me stop share.
Yeah, thanks. Yeah.
Yeah, so can you see my hub now?
We'll just
One
spin it.
minute, 1 minute. We are paying. Yeah, that's fine now. Yeah.
Can you see my hub, right? It says
Yeah.
0, 1. Okay, then it's the same thing, 0, 2, 3, 4,
Perfect,
5,
perfect.
6, 7.
This
Okay.
is good. This
Okay,
really
okay.
helps.
This is what it will do. So this is what it will look like, and it has loaded all the programs. So you just select. It's the same functionality as Pipe. And
Correct.
if the kids want to be creative, you don't have to use this 1, 2, 3, 4, 5. You can use A, B, C, D, something like that.
Yeah,
But
perfect.
I think 1, 2, 3 is much easier. So we just kind of stick to familiarity and so on, right? So this is how it will look, right?
Perfect. Thanks.
Yeah. So yeah, I think that is pretty much it. I mean, it's not very complicated, like once you start, let's say, coding with it, it is so intuitive. You just do step by step. So some suggestions for everybody, right? One thing is determine your starting position and stick to it. Okay, don't change the starting position. If you need, let's say, some, aligner or whatever, just make sure you're very consistent. That I cannot emphasize that enough. Even small changes, like minor changes to your starting position, can change other things because you're looking at millimeters, right? So this is something you all have to be super careful. So we have gone to lengths where, like in our run 1, there is one position, and then run 2, 3, and 4 is the same position, so that the kids remember. Because when you're in pressure, if you are having, different starting positions all over, you tend to make more mistakes. So you have like very consistent starting positions. Make sure you're starting from the same position all the time.
No,
Okay,
Kinjal,
so that's-
you're precisely talking about the problems that we are facing. A little bit of positioning, dispositioning here and there. The whole run goes for a toss, and we end up uprooting the missions at times.
Yeah.
So I was just wondering, is it programmatically possible to position the robo at the beginning of the run? I know there is no XY positioning for the motor, so that the robo positions itself, so that the precision is left to the robos rather than human intervention out there.
It is possible, but you don't have time. You will waste 2, 3 seconds, 4, 5 seconds, whatever time it takes to position it. And I think the main challenge that the kids will have is, like they have to do many things, right? The two technicians, as they call it, they need to get the robot, change the attachments, and do things. So yes, of course, you can do some elements of positioning. For example, what the team Monet Masters has done is like, let's say in run 2, for example, when they come back, we have an arm that used to stay up, and they had to kind of take out the attachment and make it down. So we just made the change that while it's coming back, it should just go down automatically. So we are already kind of pre-fetching some conditions for them to spend minimum time in the home area. So you could do all of that, but I think the humans will always be faster compared to the
No,
robots.
definitely. I'm just wondering, not like moving it a great distance, but if they know that it is to be in the left-hand corner or maybe on the horizontal line, and if there is a little bit of millimeter, centimeter kind of precisioning that needs to be done, the robo will correct itself, that much, so that the precision is not lost. Is there any way of doing that? I mean, because you cannot really give it an XY coordinate to go to this particular position or navigate to that particular position. But just this position itself so that it fits into just wild thought.
It may be possible, like the team hasn't explored this yet. What they are doing is they're just using the walls. Like, at the starting position, you just use the wall. You know that it is straight. You know that in the robot there is a back thing. And all you need to do is align it to a line, one of the lines on your home area, right? And sometimes, by mistake, there's a little bit of angle here and there that can make a change. So you just like use some kind of an aligner on that line, and you just like, slide it back on the wall, push it a little bit on this side, and that's consistent. I think so far what we have seen is that approach is working magic for everybody. We have seen that people are able to consistently do the runs. Now, again, keep in mind, this is not like a, like a professional class robot. So you can't expect like super precision. But given the combination of PyBricks and the way these guys are positioning, I would say I'm reasonably happy with the results compared to last year.
No, I get it.
Yeah, I think a lot of it is just practice. Like the kids need to practice the runs. They have to just like time themselves for 2 minutes, 30 seconds and just keep on practicing it. So I think some of you may have seen the team kind of doing all the missions in the scrimmage event that we had. That time they were taking about 6 minutes, five minutes. Okay. Right now they have been able to get it down to 2 minutes, 30 seconds.
Wow.
And it has been a combination of, like integrating the attachments. They were spending a lot of time coming out with the attachments, and also now they've figured out a way to integrate it. And a lot of practice, right? They were also like fumbling, like in the sense which, figure will go where, which expert goes where. With practice, they are all now doing a lot better.
There are a lot of videos on stuff like YouTube when you search up masterpiece, and there's a lot of them which claim that they can get all of the points in a run. But me and my brother, we were having a look at them, and we realized that none of them are actually leaving any margin for error. So, like, I remember one of them, it completed all of it, and it was legit, but it took 2 minutes and 27 seconds. So even if somebody fumbled for 3 seconds,
Yeah.
then you would have lost some of your points.
That is true, and that will happen. Okay, that will happen. So even you could have the perfect runs and everything here, something will go wrong there because then, the mat is new, the robot slipped, or in pressure, somebody just kind of forgot to do something, right? So, and it's okay. It's okay. It's a part of learning. Okay, that's why you have 3 runs. But that's why I think practicing in like 2 minutes, 30-second format is very, very important. Right? As a team, you really need to focus on that. That's the only way you reduce your errors, because then you will have this memory, right? You just know in pressure, you just know I need to do this along with the other person. And you have to forget about what everybody, just focus on your work. The other person is doing there, and you just work like a tight team. And that's how you kind of reduce the time. So yeah. So yes, practice, positioning, and kind of get to the PyBricks. I think these 3 things should help you guys really go to the next level. Yeah. Sorry, someone was saying something.
Can we get the battery percentage, of the robot, but in percentage?
Yes, you can. I think I have seen a code somewhere, which actually talks about the battery percentage for the PyBricks, right? So they have just written a code which is basically measures the, the top end of the voltage, the lower end, they calculate current, and on that basis, they can give you the battery percentage. Having said that, I have found that, the PyBricks basically, unless and until it is really like, the battery is really kind of just almost in 10 or 20%, it does fairly accurate. Whereas, what we noticed with the Spike Prime was that the moment it went like below 80%,
yeah,
we could just not figure out, right? It would just go all haywire. And if you
it's
like,
a drunken robot.
Yeah. So on the other hand, with PyBricks, we keep using the robot till it literally like, we have had 2 or 3 runs times where it was like literally, it started behaving really weird. That's when we realized that, oh, okay, looks like this battery has, like died. And that's how we were able to kind of go. So I think, again, for your regionals, a good thing is just make sure that your robot is 100% charged. okay, and just carry like a mobile battery pack. So between the runs, let's say what happens is like, you do the run one, somebody just, then puts it on charge to that battery pack. So just to make sure that it doesn't run out, being on the paranoid side, you can just do that. And that will just ensure that you're not running out of battery. And I have seen that in some competitions, someone forgot to just charge their battery and their robot just died on the competition mat. It
Maybe
happens.
we could like incorporate some sort of cage to keep a power bank inside the robot at all times.
Yeah.
No,
when-
keeping a cage will make it quite heavy for the robot.
Yeah, you will add weight to
Yes.
it and it will be problem. So it's
No, just get a normal power bank.
yeah,
I don't
you just
need
need
a
2 minutes 30 seconds, right? That's what the runs are, and that's fine. But I mean, with PyBricks, you can use it for hours together without losing accuracy. That's our observation so far.
Yeah, because especially on the normal app, I found that when it went below 40%, the center button started to like flash orange, and I found that I'd have to change the code very often and put more
Yeah.
power in because
No,
it kept
yeah.
slipping.
Yeah, exactly. That's the problem. That's the problem with Spike Prime. We
Just-
face through that. Yeah.
Just bring a power bank, and right before the tournament starts and everybody starts doing their stuff, the other teams, we can charge the robot on the power bank while they're doing their runs and everything.
Yeah.
All right. Any more questions?
I think there are like two more. Just bothering you too much, but if you look at mission number 2, right, where it says that you have to, speak to your opponent team to understand what color they are. I don't know what's the name of that mission. Immersive? No. What's it?
Yes.
Movie theater, is it?
Yeah, for the bonus, right? For the bonus, yes.
For the bonus, that's right. So, what is the setup like? You've got literally a table next to you. You need to speak to them to understand. We were just thinking that if we can use a force sensor to modify the behavior of the robot at runtime, if they say that we are also doing ping, we'll press the force sensor twice. That will indicate our robot that you have to go and nudge the mission twice so that it goes to pink or orange, whatever it is.
Or you can also think about something simpler as well, right? So again, there are different strategies. For the Monet Masters team, they are just going for pressing, the changing the scene once. That gives them like 20 points. And like what we hope is that we probably try to talk to the other team to say if they also are willing to do that 20 points, then it gives both of them maximum points, right? They get 30 more, we get 30 more. So that's what we are planning. But what I've seen many on most of the videos, they always press it twice to get the 30 points, and they are just assuming that the other team is also going to do the same, right? So they are losing 10 points. So that's what we have done. But now let's say if you want to have that flexibility, there are a couple of ways to do it. You can use the left, right buttons, right? Either that's one way, or you could just have different program numbers. So you could have, let's say, I don't know, let's say your program number 4,
Right.
it will just press the lever once, and your program number 5 presses the lever twice. So it's the same program with a small change. And let's say you go and talk to the team. They're saying, hey, are you guys, doing it once or twice? What scene? And if they say, okay, they're going to do it for twice, so then you just run your program 5 and that's it, right? You maximize your time. If they say, no, we're just trying to do it once, then you do it that way. But yeah, it does involve talking to that team before. It should, like, you should have that time. And it's a good thing. If you can do that, it's a good thing.
And just one last one. Any comments on passive attachments on motorized attachments? In the team right now, we are encouraging the use of passive attachments, but we just don't want to overdo it at the expense of completely bypassing the mission or making it.
Yes. It's a very good question. If you ask me my perspective and what I've seen from last 2 seasons and also a lot of runs, I think a combination of active and passive is the best rather than going just one way or the other. Because there are areas where passive attachments can be very fast. Like let's say if you want to push something, whereas a motorized attachment may be slower, but then it is more flexible. Right?
I think it's more to do with the time it takes to put motorized attachments, because if you put the motorized attachment, you want them to be really holding strong onto the motors, otherwise they get flimsy and
Okay, so that's the other thing that the team Monet Masters worked on. They built slip-on, slip-off attachments, and they put a frame around it, right? So, I mean, if you see the scrimmage runs, they all had separate attachments. So they learned from it, and that very day, basically, we just ended up putting frames and attaching them. So it's now more sturdy. So, but again, I would suggest that, you explore a combination of passive and active. There are definitely areas where passive will be better. And there are areas where active will be better. So as I said, right, active attachments can be more flexible. Passive are a bit more rigid, right? Depending on, like position and all that. There are people who have tried to do things with just passive attachments, but then you have to do a lot of changes, right? So it comes down to how do you minimize the time in your home area so that you can, give robot the time to finish all the missions.
Sure. Thanks, Kinjal.
Okay, Yaksh, you had some question?
Aren't passive attachments not quicker to collect experts and whatever and to do the mission? Aren't the passive attachments are faster, aren't they?
Yes, they can be faster. Yes.
Would you recommend that we take a laptop to the competition? So say our robot fails on the day and perhaps like one of the codes gets deleted, then we could have a backup version, say on the cloud, that we could download quickly?
Oh yeah, absolutely. You need to have one laptop. Absolutely. Right? Don't assume that it's gonna be just fine, because let's say you found out, you went there and you saw that one of the turns is getting crazy on a new mat, right? So that's where your commented code comes in very handy. You look into it saying, okay, this turn is happening fast. Can I just quickly add a slower speed, right? And then try that again. So you do get some practice sessions. Try to do those practice sessions on the new mat. And yes, do have one mat. Now, keep in mind that the parents and coaches are not allowed to help you. So you as a team have to do it. Specifically on that day, you have volunteers kind of observing and so on. So as a team, you got to be able to do your own fix. Even if the robot falls down, if attachment breaks, right? None of the parents or coaches should be helping. You have to be able to do it on your own. So you can get the help now, but in the match, no, it's all to be done by you guys. So yes, I definitely recommend that you be prepared for these kind of things.
Thank you.
Yes.
Do you need to define multitask?
Yes, you do need to. So I gave the example, right, in the code that we discussed. So yeah, you import it and then you use the multitask according to what you need to do, right? Again, don't be very like it's not a must, okay? It is just depending on your situation. If there is a situation, like when you observe your runs, you will know, hey, I'm doing these two things sequentially, right? Like especially in our case, when you have front and a back, and you are you're using the back motor, the front one, you need to kind of do something else later on, then you can say, okay, I can just do them both at the same time. Only there you use it, okay? So you don't go crazy trying to do it. It's just look into your run and see whether it is appropriate for you to use multitask. And that also if you are finishing all the projects and you're running short of time. Otherwise, it may be okay. Okay. Yaksh, you had a question?
Pretty sure there are a lot of people with some code left in their PyBricks of a lot of runs.
I'm not sure how many people are using. I know that many people are still using the what do you call the Spike Prime block code. Many people still use it. There are many new teams. Not everybody feels adventurous to use PyBricks. PyBricks has a little bit of a, let's say, learning curve. But in my mind, I was also hesitant. And once, like we started with one robot. Once we used it, then it was all great. Yeah.
I'm pretty sure Uting has a PyBrick server in his or your Dell laptop, and I have a PyBrick server.
Yep.
And I think no, I'm pretty sure somebody else also has a PyBricks in there. computer.
So I think on the Monet Masters, pretty much everyone who used to bring a laptop, they installed it when we
Yeah,
did.
I do too. I have it.
Yeah. So everybody has installed it. So yeah, you just need it basically. So yeah, I think that would be it. I would say on my side. I mean, this in my head again, I think that it's fairly straightforward. You just need to get past that initial, learning curve. Once you just install the PyBricks firmware, then it's fairly straightforward. It's quite intuitive. And yeah, I would definitely recommend to give it a try, especially if you have 30th March. I mean, I would think that, yeah, you will make very quick progress. You will make very quick progress and a lot of less frustration. Okay. All right. Any more questions?
No questions, but a massive thanks for your time, Kinjal. Really, really appreciate it. Both me and my husband as mentors, we have no idea of what you were talking till you actually showed us. And I think the kids take the ownership from here on, and we'll see what we can do.
Yeah, that's very good. No problem at all. I'm on holidays, so I said let's just get it done today. Yeah, I'll once it's 2nd Jan, and I'll be just swamped by work. That's
Brilliant.
Definitely
I'm on a
help
holiday
you.
as well. I'm learning something new, extremely different from what I do.
Yeah. I think it's a lot more. I do have an idea that maybe we'll just take some more dedicated sessions on the PyBricks tutorials, because these drive base and other commands are very powerful actually. But I think we have to balance it out, like not go too crazy on programming, because the kids also have to do the innovation project. They have to work on their robot design document and all. So this time, and again, as I said, right, in our team, we have really very young kids and some who have been there, right? So we had to really cater to everybody. So we kind of tried to get not too crazy, but still get everybody onto Python this time. So I think, yeah, they're doing well. And next year, once we are past the regionals, and I don't know if we go to nationals, we don't know, but then we'll just start kind of delving deeper into the PyBricks, because it's quite powerful. So next year it can be much better, right? It's all about just then focusing on the mission and moving forward with that. So
I think Kinjal, as I said, our catch up in Camp 1 has been really helpful for the team. The team was really frustrated with the spike prime and the behavior of the robo. We switched at the right time. The moment we came back from Camp 1, the team was bang on to PyBricks, and they've really made very good progress. Thanks a lot for that direction, and thanks for your time.
it's not me. I just told you guys what was working for us. It's the guys at PyBricks who have been doing all the work, right?
No, that's true, but that direction itself was quite helpful. We did not even know that PyBricks existed till then.
Yeah.
Thank
Okay.
you.
Thank you very much, Kinjal. Thank you for
Well,
your
thank
time.
you, everyone. Yeah, thank you, everyone. So once this is recorded and I get the link, I'll just send it over on the group chat so you can also have for access. And I'll see if I can put it on YouTube so that, yeah, the broader team can also access it. Okay. All right. Thank you, everyone. Have a great competition
evening.
and keep having fun.
Thank
And
you.
on the
Have a
20th,
lovely new
right?
year.
Bye.
Have a lovely new year, Kinjal.
Yeah. Thank you, everybody. Bye-bye.
Thank you. Happy New Year.
Thank you.
Yeah, I'll bet.
Happy New Year.